Do you wanna talk a little bit maybe about the Higgs boson now, like talking about your LHC experience, a Large Hadron Collider experience? Because I think that's something that maybe our listeners would love to hear, because we've already spoken to a professor part of the Atlas experiment, as we were talking to you before the conversation, Dr. Pekka Sinervo, part of the Atlas experiment. So maybe we can talk to you now, part of CMS, right?
CMS is way cooler than Atlas.
CMS, way cooler. Let's hear it.
Way cooler.
Let's hear it.
So, well, I will answer that, but let me plug of two things.
Okay.
One, a book not by me. It's a book by Ian Sample by the name of Massive. This is a fantastic book. It is the history of the creation and search for the Higgs boson. Everybody hears about Peter Higgs, but he wasn't the only one. And this experiment talks about who talked to who back in the 1960s. And it's a fantastic book, one of the best histories of the Higgs. So I strongly recommend that. In addition, if you want to hear something about the discovery, I'm really fond of my book, The Large Hadron Collider, which has the experimental side. It's the I was there and what it was like and so forth. So it'll give you more details than what we can talk about here. So yeah, that was very cool. It was a very interesting business because, in the I guess the probably early 2000s. We didn't really have much information on what the mass of the Higgs was. Back in 1964, we had no idea at all. But over the years, we had ruled out regions of mass. And so by about when we'd started the discovery, we had ruled out a mass of a Higgs boson below 114 GeV. And a GeV is about the mass of a proton. It's not quite, but round numbers, it's about 114 times the mass of the proton. It had to be heavier than that. And we knew from theoretical concerns it had to be less than 300 times the mass of the proton. So that's kind of where we were. So there was a big rush, a race to find the Higgs boson, because at the time, the Fermilab accelerator and the Cern accelerator were both sort of operating and looking for things. And it's kind of weird because at the time, I was both a scientist on the Fermilab accelerator and a scientist on the Large Hadron Collider. So I was competing with myself. Now that wasn't unique. Many of us were doing that. It was a very bizarre time. So Fermilab actually ruled out the mass of the Higgs. It couldn't be in the mass of about 160 times the mass of a proton. So we were starting to get down to, the Higgs, if it existed, was probably between 114 and maybe 150 times the mass of the proton. That's where it was, if it existed, but we didn't know if it would. Mm-hmm. And so, we had this humongous rush, and it turned out that the Cern collider collected enough data to make the measurement first. And so on July 4th, 2012, we announced that we found the Higgs boson, which had a mass of about 125 times the mass of a proton. So what is the Higgs boson and what is that all about? Well, that's kind of a cool thing, because we talk about the standard model of particle physics, which says that there are quarks and there are leptons and there are force-carrying particles. But in the sort of the simple, most theoretically pure version of the standard model, it predicts that all the quarks and leptons have zero mass. And we know that's not true. I mean, after all, electrons have mass, and the top quark has a mass. All of them have mass. So what happened in 1964 was these researchers, of which Peter Higgs gets the sort of the credit, they came up with a band-aid to the standard model called the Higgs field. And so what they did is they said, if there is a field that permeates the universe, this energy field will interact with the particles and give mass to the other subatomic particles. But we didn't know if it was true. And in fact, until 2012, it would have been even cooler if we had this thing at 114 GeV and if this thing at 106 or 50 or so GeV, and we slowly killed it, and then we got to the point where the Higgs boson wasn't there at all. And that would have really shaken things up. But as it happened, the prediction was correct, and we discovered this this subatomic particle. Now, hold on, I'm going to cough here for a second.
Sure. Go for it.
Too much talking.
No worries.
So, anyways, the thing that gives mass to subatomic particles is not the Higgs boson, but the Higgs field. And that is this energy field that's everywhere. It's very much like Star Wars, Force permeates and surrounds us and all that. But that field can vibrate, and so the Higgs boson is vibrations of that field. So what we discovered was the vibrations of the Higgs field, and that's what we did. and it was truly amazing. And in 2013, just 15 months or so after the discovery, Peter Higgs and Francois Englert shared the Nobel Prize for the discovery, not for the discovery, but for the prediction of the Higgs boson.